Hi everyone, my name is Jordan. In this video, I would like to share about my final year project for the School of Computer Science and Engineering at Nanyang Technological University, Singapore. This project is titled KUBEINN, and without further ado, let us begin. Over the past decade, we have seen a rise in popularity of cloud computing and containers. To share some numbers, global end-user spending on public cloud services are forecasted to increase to a whopping $304.9 billion by 2021. Of global organizations, 75% will be running containers in production by 2022. One particular related technology, the container orchestration platform Kubernetes, is expected to be adopted by a significant 47% of respondents to the RightScale State of Cloud Report 2019. So, given the rise in these technologies, many organizations have created or are creating their own cloud container service offerings. When we look at the public sphere, Google offers the Google Kubernetes engine. Similarly, Microsoft offers the Azure Kubernetes service, while Amazon offers the Elastic Kubernetes service. Now, under the private category, we are indeed very honored to have had the privilege of working with the creators of several other private cloud container service offerings. This includes Nautilus by the Pacific Research Platform, the Makers Platform by the Thai Research and Education Network, and the Projects Portal from the National Supercomputing Centre of Singapore. We also have the Asia Connect Research Platform by the Singapore Advanced Research and Education Network, or SingRN for short. Now that we have ourselves the goal of creating a cloud container service offering, we asked ourselves, what are the challenges to building such an offering? So to answer this, let's begin by meeting two people. On the left, we have Alice, who is a cluster administrator. On the right, we have Bob, who wishes to use the resources in Alice's cluster. So a conversation between Alice and Bob might go something like this.
Hi Alice, I would like to use your cluster for my project.
Sure, Bob. But first, I'll need more information about you.
Sure, I'm from the finance team and here is my email.
Thanks, Bob. Next, can you tell me about your project?
Here are my project details.
Let me record that down somewhere. Your project namespace is ready. Here you go.
Thanks, Alice.
A few moments later.
Hi Alice, I would like to register for another project.
Sure, Bob. Tell me your details, all over again.
So from this exchange, we can observe that a cloud container service offering will typically involve a high degree of interactions between cluster administrators like Alice and cluster users like Bob, even for something as simple as provisioning resources for a project. So this brings us to our first challenge. In a cloud container service offering, cluster users may find it difficult to access cluster resources. Let's observe another situation. This time, let us introduce Charlie and Dick, who represent other tenants in Alice's cluster.
Hey, I can see what's running in your namespace.
So from this situation, we can see that without a consistent policy to ensure proper configuration, a cloud container service offering faces challenge 2, which is a lack of secure isolation among tenants. Now let us consider a third situation. What might cluster administrators like Alice be thinking about when she has multiple tenants in her cluster?
I can't remember how much resources I've assigned to each Bob, Charlie, and Dick. I have no idea how much resources Bob consumed over the past week. Do I even have enough resources in my cluster to support all these users?
So all of these questions point to one common theme. In a cloud container service offering, the third challenge would be the lack of accountability of resource allocation and usage among the cluster tenants. So, given these challenges, how can we go about creating a cloud container service platform? Allow me to introduce you to my project KUBEINN. Our KUBEINN's objectives are centered around the challenges of a cloud computing service platform. To overcome our first challenge, KUBEINN aims to facilitate access to cluster resources. I would like to introduce two screens here. On the left, we have the Cluster Administrator Web Application Portal. On the right, we have the Cluster User Web Application Portal. So, when a new user wants to join the cluster, he can proceed to register on the cluster user web application portal. So once a user sends in a registration request, the cluster administrator can first log into his portal, right, and review the registration request sent in by the user. Now, if everything is okay, he can approve the user, and the user is now registered. So upon approval, cluster users can now log in, right, and they can proceed to create their own projects without any help from cluster admins. And yes, so here we go. We can see that the project has been created. To overcome our second challenge, KUBEINN aims to enforce secure isolation among tenants. Previously, we have created a project, so now a cluster user can access the resources by using the configuration file as shown. Okay, so now let us try to get all the resources in our namespace. Now as you can see, our request was successful, but there were no resources created in our namespace yet. Now let us try to get resources in a different project namespace. Now from the error logs, we can see that this request was not successful. So this demonstrates a few things. It shows how KUBEINN enforces secure isolation in several ways. First of all, cluster users are only limited to accessing resources in their own project namespace. Second, when it comes to network traffic in a cluster, KUBEINN also implements a default network policy to allow traffic from only being exchanged within a namespace and not between namespaces. To overcome our third challenge, KUBEINN aims to promote accountability of resource usage. To start off, let us begin by deploying a workload in our project namespace. Okay, so now that we can see that our workload has been deployed, now when we go back to the administrator dashboard and click refresh, we can actually see that the pod here has been spawned and we are actually recording values. So what this demonstrates is a real-time update of all the resources used by workloads in our cluster. Furthermore, as we showed earlier, whenever a new user registers a project, he has to enter his own limits and requests. So from the cluster administrator's perspective, we can observe how much resources has been assigned to each user and their projects at the time when the projects were created. So that's our introduction to the KUBEINN project. If you'd like to find out more or contribute to the project, we have open sourced KUBEINN on GitHub. I am extremely grateful to all the people who have helped me along this project. Here are the references to the sources for these slides. And finally, a big thank you to all the viewers of this video. If you have any questions, please feel free to get in touch with me at the following links.